Alright, what we're going to start now is, well, first we're going to go take a look at the correct beam equation. What I did is I put the beam formulas from the American Wood Council on there, only because it seemed like they had a complete set. So what I'm going to do is correct this from the last video and say, well, if we had a beam in which it's cantilevered, then the equation will look much like this. So here, the way I'll do it is I'll just, here, I will, let's stop this. Let's, there's no real way I know of to, there we go. Okay, if I just copy this, I can drop it straight into here somewhere. And there's our equation. So what we're going to do is get rid of this last one we had up here and get rid of all this. And then we'll take the equation we did have down here. We'll move it up here and then put it in the context here. The deflection is equal to this, where the coordinate is measured in this direction. So what we're going to do is keep this same data. Now this is the equation I used. It just so happened when I did the flip left, right, I was flipping the coordinate from one direction to the other so that it would plot correctly. Now what I'm going to do is I'm going to show you how to put a spring load on something. Let's take our beam the way we have now. Go in, here's our beam. What we're going to do is arbitrarily put a spring at the end, say. And we'll say this spring constant is going to be, say, 100 length units or force units per length unit. So in order to get this, what I have is I have a case in which I am actually putting a force here equaling to K times the deflection. But initially when I run it, I have no deflection. So the way I'm going to do this or approach this is, here's the code in a block. I'll have one line that in that code that's associated with this load. I'll run the code, get the end point deflection, go back, multiply it times K, and put it there. And so we're going to see how we do this, and I'll go now to the code itself and show you a sequence of doing this, where I'm going to put in K is equal to 100, but during the code, if it doesn't deflect that much, I may put something else. For that matter, instead of looking at it in this way, I think I might move the spring over. And the reason I might move the spring over, and as a matter of fact, I sort of like that idea, because if I move my spring over to halfway over, then I end up with something interesting here. I'll show you what I mean. So here's my spring load here, but I have to find the middle node. So what I'm saying is, in the last example, I believe I had 10 elements, and each element was 2. So this starts at 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. The reason I drew this up here is because right here on node 10, I want to determine this force equaling to 100 times what I'll call is a variable called delta for the deflection. Okay, with that, I'm going to stop the video, go to the other one, and we'll go from here.